So in this video, I'm going to discuss the forever winter problem which occurred in today's Code Forces challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem statement is very simple. It is given that, okay, so before understanding the problem, let me tell you what is a snowflake graph. The snowflake graph is basically there is a center and there are x edges coming out of it, and in every edge there is another vertex which has y edges coming out of it. Okay, let's say there are y edges, that is over here y is 3 and x is 1 2 3 4 5 6, right? So over here x is 6 and y is 3 and there are vertices over here. Okay, so I hope that is like this is over here, the vertices over here. So this is what the basically the question states. So you're given the number of vertices and the number of the number of edges, and for every edge, okay, so for every edge you're given the connecting the whatever vertices that edge connects, and you have to find the value of x and y for that snowflake graph. It is guaranteed that the test cases are provided in such a manner that there will be a snowflake pattern in it. So the problem is very simple. For every element from, since it is a graph, so all the elements are in the range from 1 to n, so you have to find the degree of all those elements. So let's say for 21 20, this if there is a vertex between 21 and 20, so that vertex contributes to 1 degree for 21 and 1 degree for 20. So what is basically we have to do, for every u and v that we input, you have to make the degree of u plus plus and degree of v plus plus. Okay, so this is what basically the question demands. So once you're done with this degree thing, so you can see one thing over here, that there is only one vertex which has a degree equal to x, and there are x vertices which has a degree which are equal to y, right? So you have to find the value of x and y. So what you can do, we have to find out that the remaining has a degrees of, okay, my mistake, it is y is equal to 3, so that doesn't mean that all these are having a degree of 3, all of these are having a degree of 4, that is y plus 1, because they are also connected to this. So we are not only considering this 3, we are also considering this. Okay, so this is what the question demands. So once we are done with it, so let's it will be better if we do it with an example. So let's do it with this example. So let's see how the degree array will look like for 1 2 3 4 5 6 7, right? So the degree of 1 is 1 occurs 2 times, right? So 1 occurs 2 times, so 1 degree of 1 is 2. 2 occurs 1 2 3 times, so degree of 2 is 3. For 3 1 2 3, so degree of 3 is also 3. For 4 it occurs once, right? So degree of 4 is 1. For 5 it occurs 1, for 6 also 1, and for 7 also 1, right? For this, so for all of them are 1. So there is only one which has a degree of 2, and the remaining there are 2 elements which has a degree of 3, and we have to ignore all those elements which have a degree of 1. Okay, so there are 2 elements which has a degree of 3, that is this. There are 2 elements which has a degree of 3, and there is only 1 element which has a degree of 2. So what is the answer going to be? The answer is x is equal to 2 and y is equal to 3 minus 1. As I stated that there is 1 extra over here, so 3 minus 1, so it is 2 comma 2, right? See, it is 2 comma 2. So remember one thing, that there may be also a situation where there will the degree graph may look like 4 4 4 1 1 1, okay, 4 4. So in this case you may say that, see, there is 4 over here and there are 4 vertices which are there which doesn't has 1. So over here it will be a little bit of anomaly and little bit of like difficulty will arise to detect what is the value of the x and y. So for this case you can simply take x as 4 and y as 4 minus 1. So I hope, so this is just a case I just explained. Okay, so for over here it was this was 2 and this was 3, so x was 2 and y was 3 minus 1, right? For this also, if you check, x would it would be in the form like 5 comma 4 comma 4 comma 4 comma 4 comma 4 comma 1 1 1 1. Okay, so that is, there will be a vertex having degree 5 and there will be 5 vertices having degree 4, and the remaining will be having 1 over here. Okay, like if you go for it, you can check it. And for this also similar thing. So this is how the code works. The calculation is the main part of the code. If you can do it very wisely, so you will get the answer. So that's it from my side. Thank you.